Class, welcome back. Today we are focusing on section 4.4. We're talking about congruent triangles. Okay, so far we've talked about congruent sides, or maybe not even sides, I should say, congruent line segments, congruent angles. Now we're going to kind of put these two ideas together and talk very specifically about congruent triangles. Now, I'm very sorry, I already filled in these blanks. I had a little coughing fit, so I just restarted the video because it was early enough. But this is what we need to know. For figures to be congruent, they must have the same size and the same shape. Alright? What do I mean by that? Well, I mean that if this is my first picture, the other picture has to be identical. Alright? Absolutely identical. That's not even that great, but hopefully you get what I'm trying to say. We can't say something like this. Right? This is no good. Cross off. Yes, this is okay. Alright? So, when we talk about congruent figures, we talk about corresponding sides and corresponding angles. They have to be in the same position. Alright, they have to be in the same position. We'll get a little bit more into that in a little bit, but I basically just mean that when we have congruent triangles, all of the different parts have to line up very nicely with the parts of the other triangle. And it really matters the order, okay, because we need to be able to understand what matches up with what. Alright? We'll get into an example of that in a little bit. Now, polygons are congruent if and only if their corresponding angles and sides are congruent. Alright? So all of the different angles and sides that correspond to one another must be congruent in order to call the polygon congruent. And again, in this case, we're talking triangles. Lastly, in a congruence statement, the order of the vertices listed indicates the corresponding parts. Now that might not make sense right now, but it should as we move down to this next section. Alright, when we look at this picture, I can either look at the picture itself, or I can look at my congruency statement or congruence statement, and I can already determine what angles match up with what and what sides match up with what. So real quick, let's look at the diagram first. And let's say I'm going to go angle A, angle B, angle C, and I need to know what lines up. Well, angle A is over here. It has a single arc mark. So I know that it has to line up with the single arc mark in the other picture, D. B is a double arc mark, so E. And lastly, C, which is a triple to triple, so F. Alright? Easy enough. Now, for sides, slightly more difficult, but again, not that bad. I'm going to go ahead and I'm going to start with side AB. And then I know I'm going to have BC. I'm just going to go around my triangle, and then lastly CA. Alright. Now I need to know what lines up with AB. Well, AB has a single tick mark, so I know that I'm over here at ED/DE. Which one do you think I would prefer you to write? ED or DE? I hope you all said DE. And the reason is because I want to go in order. What corresponds with what? Notice vertex A lines up with D, so I would want to go in the same order as I went. From single to double, single to double, single to double, single to double. Now, BC is double to triple, so that means I want to go double to triple in my new one. Lastly, I went triple to single, CA, right? CA is triple arc to single arc, which means I want to go triple to single again, FD. D. Now, one other thing that I think is really important to kind of take note of, you don't even need this picture to do this. You really don't. What do you notice about A and D in my congruence statement right here? They are both lined up perfectly. So I knew that because they were both in position 1, like my first spot, AD, AD. Which means the second slot to the second slot, B to E. Oh my gosh, it worked. And then of course, we can change colors even one more time, and we can say C and F. But Mr. Rabins, those are just single letters. Does it work for sides as well? It sure does, guys. Look at what I do. If I look at my first two, so AB, that means that if it's in the first two slots, AB of our first triangle, it needs to match up with the first two slots of the second, DE, and it does. Okay, now I'm not going to go through every example there, but I need you to know that just having this right here is enough to come up with your corresponding angles and sides as well. All right, let's move on. Okay, this next page here has a bunch of different properties, two of which I think are going to be super easy. One is a little more difficult. And the little more difficult one is this first one, reflexive property. The reflexive property is basically just saying that an object is congruent to itself. All right. Now, when I say object, I mean you can pick any segment and say it's congruent to itself. So like AB is congruent to itself. However, we want to use the reflexive property to find shared objects. Okay, because if we can find something that's shared, that means that an object is going to be congruent in both of my triangles. All right, in both of my triangles. So for example, if I take a look at this picture and I highlight this left triangle, ABC, and I highlight this right triangle, ACD, does anyone notice, was there anything that you can find in both triangles, in both pictures or both sides? I hope you agree that AC, this segment right down the middle, is a picture, or it's not a picture, an object in both triangle ABC and ADC. And so this is what I'm talking about. If I can find something that's shared, then I know that it is going to be congruent to itself. All right? Now the next one, slightly tougher, but it works the same way. I'm going to do the same exact thing. I highlight, and maybe I highlight here. Oh, wrong pen. Shoot. Now be real careful on this one, guys. I need something that's exactly the same in both pictures. Exactly the same. So like this DB right here, I wouldn't call that the same just because this DB has no bearing on my yellow triangle. All right? I want to find something that is the exact same in both triangles that I can kind of say matches up so that you can use it in both triangles to say they're congruent. So I look, DB is not AB, BC is not BE, and then definitely DE and AC are different. Okay, so no sides are shared. How about angles? Angle D, no, it looks like angle D lines up with angle C, so that's not shared. E and A are definitely different. What about angle B? Oh my, yeah, there we go. Angle B, guys, is the exact same angle in both the yellow triangle and the green triangle. All right, so angle B is what's being shared. Angle B is what I need to know is in both triangles. All right, we're going to practice this more in class. Now, the next property that I need you to know is something you already know. Vertical angles. We know that vertical angles are what? Congruent. Okay, we know they're congruent, so you really just have to be able to recognize them. And where are vertical angles? Vertical angles are always kind of like that bow tie. They're always formed by two intersecting lines, so I'm going to say something like that. Now, I would want to maybe label this a little nicer, so I could say HJI is congruent to LJK. And that is that. Alright. The last one, I don't know if we've really talked about it, but this one should be pretty straightforward. Just like vertical angles are congruent, right angles are also congruent. Okay, so we know that right angles are always 90 degrees, so if I have two angles that are 90 degrees, then of course they are going to be congruent. So what can I say? Angle A is congruent to angle X. Alright, right here. Okay, we're getting there. Let's do some practice and then we'll call it. Alright, in problem number 1, it says to identify the congruent corresponding parts and write a congruent statement for each pair. Alright, this is just matching up angles and sides. So just look at arc marks, tick marks, etc., etc. Let's do angles first. So angle A, which is a single arc mark, lines up with angle D, right? Then let's say angle B, which is a single with a dash. E is a single with a dash, so angle E lines up with B. And lastly, doubles C and F. Cool. Now, for sides, again, match up the tick marks, or match up the proper markings. So I'm going to go AB here. That's my single. So I'm going to say AB. And if I went AB, I need to go DE. Why? Because AB is single to single with a dash, so I need to go single to single with a dash in my other triangle. Now I'll go here, BC. I'll just kind of go around now. BC, so EF, and CA, which is double to single, so F to D, double to single. Okay, now my congruent statement, you just need to make sure everything lines up with each other. So I'm going to say triangle ABC is congruent to triangle, and if I go single to single with a dash to double, then I need to go single, single with a dash to a double in the next one, so DEF. Alright? This next one, this is a good example of you not needing the picture. Remember that the order of the lettering gives everything that you need. So we know that if you're in the first slot of one, you match with the first slot of the other. So angle G, angle M. Keep going. Angle E, which is second, matches up with angle T, and third. So angle O and angle Y. Sides, it's the same thing, it's just now you have pairs. Okay, you're going to have pairs of letters. So let's go GE, first second. GE, first second to first second. MT. Let's go second and third. So EO, which is second third of my first, second third of my second is TY. So I write it. The last one, you can go third to first or first to third, whichever way you think about it. I'm going to go OG, which means you have to go from third to first, so YM. Perfect. Okay, we're getting there. Almost done. When we look at a picture, we need to be able to recognize and see what we already have as being congruent. That's going to help us when we start to write proofs in a couple of days. Excuse me. So identify the congruent corresponding parts of the triangles, include vertical angles and the reflexive property. Alright. On this, we're not going to be able to mark everything because we don't know for sure. However, we do have some markings very clearly that we can write for sure. So I definitely see arc marks at Y and V, so I can say angle Y is congruent to angle V. I also see some tick marks. So if I say YX, excuse me, yx, would I say xv or vx? Hopefully you agree with me. We would say vx, and the reason is because you're going from a single to a no arc mark, single to no arc mark. There's one more picture, right? There's another blank, or not another, there's one more phrase that we can say. And you need to be able to recognize our properties, okay? What else do we see in this picture? It kind of looks like a bow tie to me, which means I have a vertical angle, all right? You need to be able to recognize from a picture that you can add in some markings, all right? I know that angle y, x, z is congruent to angle, so I went single to double to none, so single to double to none, angle VXW. Why couldn't I just write angle x is congruent to angle x? Because there's more angle x's that I don't really care about in my picture, okay? So you need to be very specific and let me know exactly what angle x you're talking about, because there are multiple angles at x. Okay, almost done. I know this is taking a while. We also need to be able to mark. Like if I give you some concepts, you need to be able to mark up a diagram. All right. So first things first. E is the midpoint of BD. Well, here's BD. If E is the midpoint, then we know that a midpoint does what? It bisects, or it splits into two congruent pieces. So that means BD is split into two congruent pieces. So I show that using tick marks. Now I also know that AB is parallel to CD. So AB is parallel to CD. Not bad. Angle A congruent to angle C. That one's nice and easy. Alright, there's one more, guys. Again, very similarly to number 4, like you need to be able to recognize in a picture where you can just make markings, okay? You need to look out for shared sides and angles. You need to look out for vertical angles. You need to look out for right angles. And in this picture, I see some vertical angles. So I need to finish this picture up by drawing in that vertical angles are congruent. All right, so this is a big, long introduction to congruency. We're going to be using it a lot over the next couple of weeks. Please, please, please make sure that if you're not understanding this stuff, to get help, whether it's from me or the MRC or your neighbors. Whatever you do, just do it. All right, have a great day. See you next time.